Hello, my name is Freeborn Goodluck Otuya.
My name is Gabriel Stanley Chukwukalibia.
Welcome to Studysmart, where you learn faster and retain more.
Welcome to Studysmart, where learning meets ease.
Please like, share, subscribe, and comment. Study smarter
and not harder.
Hello everyone, and welcome to Studysmart. In today's video, we are going to be exploring set theory. Another set theory we are going to be exploring on definition of sets, we are going to be talking about how sets are being represented, that is, representation of sets, and as well we are going to be looking at various types of sets. And then lastly, we are going to be looking at the basic set operators. Alright, definition of set. Set can be defined as a collection of a well-defined object or element. And in denoting this set, if we want to denote a set, we use uppercase letters, while the collection of numbers or elements are always in lower cases. What I mean is, in denoting a set, we use uppercase letters like A, B, C, or even D. Either of these can be used. While in denoting the elements, the collection of elements of the set, we use lowercase letters like A, B, C, D, just in this form. For example, if I have this is a very good example of set, because this is the uppercase letter I was talking about, and these are the various lower cases of the elements. And don't forget, if you want to enclose a set, the acceptable way of enclosing a set is by using what we call a curly bracket. That is this type of bracket. It must be coiled in this form. That is why it is called curly bracket. Curly bracket. This means that you cannot use this kind of bracket or this to enclose a set. So that's just it. In using this, we use curly brackets to enclose the set, and we use lowercase letters to denote the various collection of elements, while uppercase letters are used in denoting sets. We are going to look at the various ways of representing sets. Sets can be represented in various ways too. We can either represent sets by listing the set, or we can either represent it by set builder notation. So let's look at the first one, listing set. So if I want to represent a set by listing it, this simply means that I am going to write down, or I'm going to write out all the elements in the set. For example, if I have a set of vowel sounds, this simply means that this is a typical example of set listing. So if I want to represent a set by listing it, I am going to write down all the elements contained in that set, which is exactly in this form. And the second way of representing the set, let me put down this set representation. And the second way of representing a set is by what we call set builder notation. How does this set builder notation work? We represent a set by set builder notation by describing that set. What do I mean? If I have A to be a set of X such that X is a represent it using a set builder notation. Set builder. Set builder notation. So, for example, let's say a set of x such that x is a vowel letters. What that means is that if I want to represent this statement in a set builder notation, this is how I write it. A is equal to, don't forget that a set is always enclosed by a curly bracket or represented by a curly bracket. Don't forget that. So A is equal to the set of x such that x is a vowel letters. So what this means is that I am only going to write down all these letters because these are my vowel letters: A, E, I, O, and U. So these are my vowel letters. So by this, we can equally use this set builder notation to generate a listing set. What do I mean? So now this is a curly bracket. Now this statement reads a set of x such that x is a vowel letter. So if I want to represent this by listing the set, what I will write is A to be equal to, don't forget your curly brackets. I have my vowel letters to be A, E, I, O, and U. And that's actually what this simply means. For example, I can have a set of x such that x is a number less, or x is any number less than 10, or less than or equal to 10. What this simply means is that if I have A to be equal to set of x such that x is a number less than 10. So if I want to represent this by listing, don't forget that all these things are examples of set builder notation representation of sets. So that is how set builder notation looks like. So if I want to represent this thing by listing it, because you get listing, sometimes you can get a question whereby you'll be given the question in the set builder notation form, and you'll be asked to represent it by listing the sets. So for example, this is what we have. X is a set of x such that x is a number less than 10, which means that I have 1, 2 to 9, but those numbers I'm going to be listing should be less than 10. It is not 10, but less than 10. Okay? So what that simply means is that I have A to be equal to, so my numbers less than 10 are 1, I have 2, I have 3, 4, 5, 6, 7, 8, and 9. So that has the explanation of this particular statement. X is a number less than 10. What if I have A to be equal to the set of x such that x is a number less than or equal to 10. This automatically means different things from this. If you check very well from here, we have less than 10, but here we have less than or equal to 10, which means that the number is not going to exceed 10, but it can stop at exactly 10. Like A equal to. So now the set of these numbers less than 10, we have 1, we have 2, we have 3. We have 4, 5, 6, 7, 8, 9, and 10. So that's